Let's continue talking about the strain in flexural members, compression control, tension control, and transition. But before that, I have to introduce one parameter that's really important. We know that from the equilibrium equation, T equals to C, we know that it's AS Fy equals to 0.85 FC prime AB, right? And then we said that A is then it's equal to ASFY or about divided by 0.85 FC prime B, right? Now from the diagram on the right hand side here, we also talked about that the strain in concrete is 0.003, and then it goes depends on the steel, depends on the which location or which stage I am, tension, control, transition, or compression, and this distance is called small c and this is called d minus c, right? That's what you said. Okay, this small c, as per the ACI code, it's equal to A over beta. Okay, so what is beta? Beta is actually just a coefficient, is 0.85 if FC prime is equals to 4000 psi as per the code, or if we were talking about in SI units, 30 megapascal. If it is more than 30, there's an equation, but we'll not talk about it now. When we talk about it if really face a problem that we have an FC prime greater than 4000 psi. Okay, so this is the C, it's just a coefficient, and we need to take an example in order to understand how to solve such thing. Okay, so let's take in a beam. We have a beam, okay, and this beam is, let's throw it here. We have a beam, and this is a beam that is under loading. Okay, so let's take FC prime here as 3000 psi. This is a reinforced beam, and take Fy as 60,000, which is huge, which is the normal one. Okay, right, so determine AC and which stage are we. So the first thing that we need to do, apply the formulas. A equal AS Fy divided by 0.85. Let's sorry, I forgot to give you A. 3 inches square is A. D is 21 inch. Okay, and B is 14. By applying the formula, A is computed as AS3 multiplied by 60 divided by 0.85 FC prime times B, and then this gives me 5.04 inch. Okay, beta is 0.85. This one, if it is less than or equal, it's 0.85. so compute what is C. C is A over beta, it's 5.04 divided by 0.85, and this is equals to 5.93 inch. So we got this small distance, the compression distance, right? So now solving it as from this equation that we saw last time, ET is equal to D minus C divided by C times 0.003. So it's equal to 21 minus 5.93 divided by 5.93 multiplied by 0.003. So this gives me 0.0079. Sorry, 76. Okay, so what does that tell me? Where is my steel? Let's go back to the same diagram that we draw quickly. That's our diagram, right? Change the color. So when we talk about the diagram, we said if it is 0.002, if it is 0.002, that means it is compression control. Going this way, it's compression. 0.005 going this way is tension. So if my strain is greater than 0.005, so it is considered as ductile behavior of the beam, and the steel is well into its yield before concrete crushes, and this is really desirable for tensile members. And just to understand from where I got this figure, it's just to quickly, I want to draw it here. It's the one that we draw previously. Concrete is 0.003. Here's ET. This is small c, and this is D minus C. So hope you enjoyed. It's the end of this session, and we'll talk about later the more parameters of steel, and what is raw balance and raw max, and what's the minimum percentage of steel required in a beam. Hope you enjoyed.